Hi, hello. Yep. Um, yes. Hi, everyone. My name is Jinghui, and I'm very happy here to present our work called Improving Text-Based Early Prediction by Distillation from Privileged Time Series Text. So this is a joint work with Daniel, Anthony, and Karin. So the task we focus on is early prediction or forecasting, which has a lot of practical applications, such as weather prediction we use every day. And there's abundant work on time series classification in this study, like research field. Meanwhile, in recent years, there's a lot of interest from the NLP community to develop text-based early prediction, because for a lot of tasks, the information only contains in the text, and it is very difficult to find those data otherwise. So there's a recent studies and the task data sets proposed for mental health monitoring, clinical outcome predictions, and other trend modeling. So the current modeling setup for early prediction is that people collect time series data, and they try to define a predictive window or a predictive time. So they use the data collected prior to the predictive time to train the model and then evaluate and test the model. In other words, the prediction windows used to train and test the model are the same baseline, using the same baseline variables, and the windows are the same during the test time and the train time. However, there is an issue with the current modeling setup, is that there's often a lot of data collected between the prediction time and the final outcome time, or the final event that we try to model it. And the data in between tends to used to be discarded during training, and they cause a lot of waste. And also in this setting, there's a potential trends or dynamics in this model in the future, kind of this future data that are not captured by the model in the training process. So actually, we propose to use this kind of data between this traditionally discarded data in this training time, and that kind of framework is actually presented as learning using privileged information before. And so actually recent work has also applied this framework to time series data, but they're mostly focusing on structured multivariate time series or univariate time series. And usually these data are synthetic and are following specific distributions. So it is unknown whether this kind of framework will be useful for textual data. So therefore, we call our new model on a text-based time series LoopIt, in short for learning using privileged time series texts. And then we try to evaluate this method on two different textual domains, on clinical applications and social media modeling. And then we also compare this with some other popular methods to leverage these data from the extended window, namely transfer learning and mixed training. So here's a basic setup for our experiments. So for example, we want to make a prediction on the for example outcome or events at the first day of the data collecting process. And so the standard training recipe uses this first day of data to train the model and test it on the first day as well. However, there's a data collected beyond this prediction window, but they are just discarded. So with the privileged information, learning with privileged information, the LoopIt leverages this data from the extended window by training a teacher model using the prolonged input window. So and then they use the teacher model, try to distill the knowledge or guide the training of this baseline model, and through a standard knowledge distillation recipe. So in here, we just use the simplest form of knowledge distillation, which is calculate the KL divergence between the teacher logits and the student logits, and interpolate that KL divergence with the standard cross entropy loss. And then we also compare two other methods to use those traditionally discarded data. And one is to transfer learning, like train a model using the extended window and then apply that model and fine tune that model to the standard evaluation and training windows. And the other one is to develop one model but feed it with prediction windows and different data with different chunks of from the time series. And then for all these windows, they are tested using the same standard. For example, here the 1-day input window. So for our experiments, we use two data sets, and one for the clinical prediction, we use the database source from a large hospital in the US, and we examine several patient risk prediction tasks and the diagnosis prediction tasks. And for the mental health issue with social media, we follow the e-risk share task, which collect Reddit posts and try to predict mental health issues on depression and anorexia. And for models, we also try to throw some variations with the representation and the modeling. And for the first modeling at the word level, we concatenate all the documents into a single documents and try to use some efficient methods because the concatenated documents can be several thousand words long. And it turns out that previous works have some promising results with some multi-layer CNN attention. So we use that with some in-domain word embedding. And also for the node level representation, we encode BERT and encode nodes with BERT and then model with LSTM. So here are our results. So the first finding is that the loop-heat methods can bring benefits to the baseline modeling, and also it can often reduce the variance of this of the performance. And the second finding is that loop-heat compared with other methods tend to better close the gap between the baseline model and the model performance using the extended window. So here are the bar at the left is the extended window, say using the 3-day, and the second bar is the standard baseline results that we have, and the red one on the right is the loop-heat method. So this is the result for the in-hospital mortality prediction. And the other finding is that when we extend this input window, say extend it from 3 days to 7 days, let the teacher models to see more data, this kind of results tends also to improve. And the fourth finding is that sometimes other results can also be better. And in this case, when predicting diagnosis the label space is much larger than the binary mortality prediction. And in this case, the model is suffer from a low resource scenarios. It does not have enough data to train. So in this case, the mixed training tend to be kind of provide some data augmentation in this case to let the model to get better results. Well, however, the transfer learning and the mixed training methods sometimes can be detrimental to the modeling. And we found in some cases, they are quite unstable with the task we examined. On the other hand, the looping method seems to be more stable, and it will not harm the results when it couldn't improve it. And sometimes it can improve it significantly. So the recent work actually also published this year showed that this kind of framework using previous time series data can guarantee to improve the results as long as the time series follow certain distributions. Meanwhile, we show that that idea can also be applied to NLP without making those explicit assumptions about data distributions. And in the meantime, we also found that this method may suffer from some L definition of the task, and sometimes it may not bring significant benefits to the modeling process. And then we think that's worthy of future investigation in this field. So to conclude, we found that using privileged time series text can be beneficial, and the benefits of these methods can be more stable than other methods we examined. And Also, the other benefits of this kind of distillation approach is that the teacher model can be more flexible. It can come from other, say, trained with data using from other modalities, or you can have an ensemble of teachers, and it can also have different types of teachers to provide the logics. And also the results from the KD literature, such as distillation, not only just using logics, but also using features and other tricks can also be beneficial in our context as well. And yeah, I think my time is up. Yep, thank you, and see you at the poster session.